Okay, we're going to solve a grams to grams problem now. Now these problems are the big problems, okay? They're going to involve 3 conversion factors. So don't get scared, they tend to be a little bit on the bigger side, so you are now forewarned, okay? So step 1, you're going to need a periodic table, and that periodic table is going to help you go from grams of A to moles of A. All right, so once you have the molar mass or the formula mass of your first substance, right, which is the given information, it tells you like 200 grams of this or 100 grams of this, that's the first step. Okay, so find that substance and find the formula mass or molecular mass of that substance. All right, then you need to have a balanced chemical equation, because only a balanced equation is going to show you the molar ratios between the 2 substances in your problem. Okay, so now you have the molar ratios. That's conversion factor number 2. The last part is going to be going from moles of substance B into grams of substance B. All right, real important that you have the periodic table handy, and you're going to need to make a second calculation for the molecular mass or formula mass of the second substance. That will allow you to go from moles of B to grams of B. All right, so basically it's 3 conversion factors. First one involves a periodic table. Second one comes from the balanced chemical equation. Third one comes from the periodic table again to go from moles back to grams. All right, watch the video. If that sounded confusing, don't sweat it. Watch the video and it will make a lot more sense at the end, and we'll revisit those 3 conversion factors. Okay, this is a grams to grams problem, but this is one of the more challenging versions of this kind of problem. And the reason why is, well, it looks like there's a lot of stuff going on here in the question. So part of the skill in being a good chemistry student is being able to decode and make decisions about information that's important and information that is extra or extraneous, as the description is. Okay, so we're going to take a look at the equation. Okay, this particular equation is balanced, and let's go ahead and read what is going on in this situation. Okay, so octane, which has a formula of C8H18, burns in an automobile engine at temperatures around 1100 or 1100 Kelvin at 4,200 pascals of pressure. If 228.46 grams of octane burns completely in air, how many grams of carbon dioxide are produced? Now, you may say to yourself, God, how would I ever be able to solve a problem like this? Okay, well, keep in mind that we're doing grams to grams, okay? And if you get enough experience in doing these kinds of problems, you'll note that grams to grams problems don't involve temperature and they don't involve pressure. So this whole business about the 1100 Kelvin and the pressure here, that's all nonsense, because we don't need that information to solve the problem. All we need is to follow our roadmap, which says that we start with grams of A, we convert grams of A into moles of A, and then from there we convert moles of A into moles of B, and then moles of B into grams of B. Okay? So that is the roadmap that we're going to follow. All right. So now that we know that, well, let's see. We have to figure out what is A and what is B, correct? So the given information is this. We've got this much octane. All right, so we're going to focus on the octane, which is here. And we need to figure out grams of carbon dioxide. Now, you may not know the formula for carbon dioxide, but it's CO2. Okay, that's something you should definitely memorize. I don't know about the octane, but you can memorize that too. You can be super smart. All right, so we'll start with the given information, which is 228.46 grams of octane, which is C8H18. Now I hate to say this, but just like every other grams problem, we're going to need to use the periodic table. And so we're going to need to figure out how many grams there are for every 1 mole of octane. So we're going to need to put grams of octane in the bottom, and we're going to put 1 mole of octane in the top. Okay? Which means that we're going to need to figure out the molar mass, and that means we'll need a periodic table. You see, whenever you figure out a mass in grams, you need the periodic table. So we're going to look up the mass of carbon and hydrogen, because those are the 2 elements that make up octane. So carbon's mass is 12.01, and then hydrogen's mass is 1.01. So let's take a look at that and work out a little mini problem here. We've got 8 carbons, so 8 times 12.01, and we've got 18 hydrogens. And the mass of hydrogen, you may recall, maybe if you saw some earlier videos, is 1.01. Okay, so I need to write that in here. Now this is quite a bit for me to add up, so I'm going to use my calculator for this part here too. So 8 times 12.01 plus 18 times 1.01. Okay, so my final mass is 114.26, and that's grams for every mole of octane. Okay, so that means that down here I've got to write 114.26. Okay, all right, now to go from moles of A to moles of B, what we need to do is we need to look at the molar ratios in the chemical equation. So the ratio of octane to carbon dioxide is 2 to 16. So to make sure that these things cancel, we're going to write 2 moles of octane in the bottom, and we're going to write 16 moles of carbon dioxide in the top. Remember, we're trying to get to grams of carbon dioxide, because grams of carbon dioxide is what they asked for in the problem. All right, one last step, and that is we need to go back from moles into grams, so we have to figure out the mass of 1 mole of carbon dioxide. And then we'll know the grams of carbon dioxide. All right, so again, we're going to evoke the use of the periodic table, and you can see here carbon is 12.01 and oxygen is 16. So we have 1 carbon and 2 oxygens. All right, so we'll work out a mini problem on the side here. 12.01 plus 16 plus 16. And let's see, that's 14, and then that's 4. So our mass for carbon dioxide is 44.01 grams per mole of CO2. Okay, again, working out a little mini problem here so that I can figure out what I need to put up here. Okay, this is the mass for 1 mole of carbon dioxide. Okay, now we've got the entire setup laid out in front of us, and we can check it out and see if all the units cancel, because theoretically everything should cancel except for this last piece, because the problem is asking us for grams of carbon dioxide, so this should be the remaining unit. Okay, so let's see, grams of octane, okay, top cancels with bottom. Moles of octane cancels with moles of octane, top cancels with bottom. Moles of carbon dioxide cancels with moles of carbon dioxide, top cancels with bottom, and we're left with grams of carbon dioxide. Okay, so we know that the units are going to work out. Everything's going to work out here. I love it. So now we're going to have to do this in our head. No, just kidding. Okay, we're going to work this out on the calculator, multiply the tops, divide the bottoms. So 228.46 times 1 times 16 times 44.01, and then we're going to divide by 114.26, divide by 2, and divide by 1. Okay, so our final answer is 703.98. This is grams of carbon dioxide, of course. All right, and that is our final answer. Okay, so there's a lot of carbon dioxide that's going to get produced from the burning of octane. All right, so that is the problem in its entirety. And if you need to go back and look at the steps, you can do so. You can hit the rewind button, and you can also download the worksheet and see if you can solve this problem on your own without looking at the video. But of course, if you get stuck, you can always press play, give yourself a little hint, and then move on. All right, that's it for now. Watch another video if you need more practice, and I'll see you next time. All right, you just watched a grams to grams problem. Now that was pretty big, I'm sure. So if it looks like it was a little overwhelming, make sure that you've watched some of the other videos where you're going from moles to moles, or grams to moles, or moles to grams, something, because this is a very, very intense problem. You need 3 conversion factors to get it right. So step 1, get a periodic table, figure out the formula mass or the molecular mass of the first substance using the periodic table. Okay, add up all the masses, and then that will tell you how many grams are in 1 mole. So that's conversion factor number 1. Conversion factor number 2 comes from a balanced chemical equation. Okay, you need to look at the coefficients of the 2 substances that you're converting between. Okay, and that will allow you to go from moles of A to moles of B. And then finally, you take out the periodic table one more time, and to go from moles of B to grams of B, you need to calculate the molecular mass or the formula mass of the second substance. Okay, figure out how much the grams are for 1 mole of that substance, and then you'll be able to plug that in and find the answer. Okay, so 3 conversion factors, kind of a long problem, and it's also important that you make sure that everything cancels properly. So double check the units, and don't be cheap, okay? Don't be cheap. Make sure you write in the units. It's very, very important. Okay, that's all I have for now. Do more practice. Take the worksheet, download it, print it out, and see if you can solve it without the video. Okay, and if you can do that, that's a pretty good sign that you know what you're doing, and then all you need to do is practice and reinforce. Practice and reinforce. Okay, always check and make sure that you're getting the correct answer. Don't solve a problem without a correct answer, okay? All right, that's kind of a long exit there, but I wanted to include a couple of extra points for you. And if you need more help, watch another video. All right, I'll see you next time.